Hi everyone, Ramesh here. Welcome to my YouTube channel. I am going to start a new series on Spring Data JPA. Well, this series is basically for beginners who want to learn how to use Spring Data JPA in a Spring Boot project. Well, this is a very basic series or a course on Spring Data JPA. But if you want to master Spring Data JPA, then I am going to suggest my Udemy course, that is Master Spring Data JPA with Hibernate. So this is a 15-hour course, and in this course you will learn everything about Spring Data JPA, and you will also learn how to build a domain model relationship for simple e-commerce project using Hibernate ORM framework. Well, this Master Spring Data JPA with Hibernate course is highest rated course on Udemy. So this is a very popular course on Udemy. So I am going to suggest you to check out this course in order to learn Spring Data JPA with Hibernate in depth. Well, this Spring Data JPA series has around 25 lectures or 25 lessons. Okay, so I am going to cover a basic features of Spring Data JPA in this series, and if you are a beginner, then I am going to suggest you to watch this series so that you will learn how to use Spring Data JPA in a Spring Boot project. Alright, let's kickstart this series with what is Spring Data JPA. Hi, welcome back. In this lecture, we'll take a look into what is Spring Data JPA. Well, before understanding about Spring Data JPA, let's first understand what is the problem and what problem Spring Data JPA solves. Well, consider we have Java application architecture over here. So this is basically called a 3-layer architecture. We have a controller layer, service layer and DAO layer. And typically we use Jpa or Hibernate to develop the DAO layer. Alright. Well, if we use Hibernate to develop the DAO layer, then we need to write a lot of code. For example, let me jump into Jpa Repository. Here I have created Spring Hibernate project to just showcase how much amount of code that we need to write in order to develop the DAO layer using Hibernate. Well, if we use Hibernate, then we need to create an interface, for example, customer DAO in this case, and we need to define all these Crude methods in this interface. Next, we need to create a class, for example, customer DAO MPL class, which implements this interface, and override all the methods from this interface and provide the implementation. Alright, so if we use Hibernate to develop the DAO layer or the repository layer, then we need to write a lot of code, right? We need to create an interface, and then we need to define Crude methods in an interface. Next, we need to create a class which implements this interface and its methods, right? Well, if you closely observe this code, for single entity, that is customer entity, we are writing this much amount of code. Let's say in your project you have a lot of entities, for example, student, employee, user, order, right? So in order to develop the DAO layer for these entities, we need to create an interface, and then we need to define Crude methods, and then we need to create a class, and then we need to implement interface and its methods, right? We need to basically write a lot of code for an entity, isn't it? And if you closely observe this code, here you can see only the difference, the entity name and the primary key type. Rest of the code remains same for all the entities. Alright, so this is basically a problem. We are basically repeating the same code again and again, right? So instead of repeating the same code, why not we basically write a library and keep all the generic code over here. So that is what the Spring Data JPA basically does. Well, I have created one more project which demonstrates the usage of Spring Data JPA. By using Spring Data JPA, we can reduce a lot of code here. For example, we just need to create an interface and extend Spring Data JPA provided interface, that is Jpa Repository Interface, and just we need to pass entity name and the primary key type. That's it. We will get a full Crude operations for this given entity, that is customer entity, right? So this is how Spring Data JPA basically provides a solution to reduce a lot of amount of code that we need to write in order to develop the DAO layer. Well, Spring team has developed a Spring Data JPA library to reduce amount of boilerplate code that is required to develop the DAO layer. For example, if you can just head over to Spring official website, here you can see under project section, you can see Spring Data Framework. Well, within Spring Data Framework, you can see Spring Data JPA module. Okay, and we use Spring Data JPA module to develop the repository layer, and Spring Data JPA basically reduce amount of boilerplate code that is required to develop the DAO layer or Jpa based repositories. Well, Spring Data Framework basically provides all these modules for different purposes, and in this course we are going to use Spring Data JPA module to see how to reduce the amount of boilerplate code that is required to develop the DAO layer. Alright, we are going to learn a lot about Spring Data JPA in this course. Well, I hope you pretty much understood what is Spring Data JPA. Well, Spring Data JPA is basically used to reduce the amount of boilerplate code required to implement data access object layer. And Spring Data JPA is not a JPA provider. It simply hides the Java Persistence API behind its repository abstraction. It means that Spring Data JPA is not a JPA provider. For example, Hibernate is basically a JPA provider, right? But Spring Data is not a JPA provider. It's simply developed on top of JPA. Well, basically Spring Data JPA is an abstraction layer on top of Java Persistence API, right? And Entity Manager is an interface of Java Persistence API. Well, basically Spring Data JPA has a Jpa Repository Interface. It internally uses all the JPA provided methods. For example, this is the Jpa Repository Interface. Okay, it has methods like flush, save and flush, save, delete, okay, exist, count, find all. So these are all the methods belongs to Jpa Repository Interface, and all these methods internally uses Entity Manager API to perform different operations with the database. Okay, so these Jpa Repository Interface methods don't directly connect to the database. These repository methods will first internally get called to the Entity Manager methods, and these Entity Manager methods will talk with the database. Okay, so this repository is basically an abstraction on top of JPA interfaces or the APIs. Alright, I hope you understood how the JPA repository methods will internally call Entity Manager methods to talk with the database. Okay, this is how Spring Data JPA basically works. All the Spring Data JPA repositories internally uses Entity Manager to talk with the database. Okay, so Spring Data JPA is just an abstraction on top of JPA, that is Java Persistence API. Well, if you are developing Spring Boot project and if you want to develop a repository layer or a DAO layer for relational databases, then you can go ahead and use Spring Data JPA. Well, in next lecture, we are going to take a look into basic flow of Spring Data JPA. Then you will able to understand how Spring Data JPA works behind the scene. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, let's quickly understand the basic flow of Spring Data JPA. And this diagram shows the basic flow at the time of accessing the data from the database table using Spring Data JPA. And if you look at the steps here, 1, 2, 3, 4, 5, 6. Well, whenever we perform any database operation using Spring Data JPA, then these 6 steps will be performed internally. Well, we basically call Jpa repository methods from the service layer. For example, let's say we want to save an entity into the database table using Spring Data JPA. Then what we basically do, we inject repository, that is Jpa repository, in a service layer, and then we call it save method, and then we pass the entity as a parameter, right? So this is the first step. Second step is like Jpa repository is just an interface, and there should be an implementation for Jpa repository interface and its methods, right? Spring Data JPA provides simple Jpa repository class which implements Jpa repository interface as well as its methods. And Spring Data JPA also provides flexibility to write your own custom repository implementation class. Alright, so consider in this flow we are using simple Jpa repository class which implements Jpa repository interface. So this is the second step. Third step is Spring Data JPA internally uses Jpa APIs. It means that Spring Data JPA is just an abstraction layer on top of JPA to reduce the boilerplate code. Okay, so all the Spring Data JPA methods internally uses Jpa APIs in order to talk with the database. Alright, so this is the third step. Now, as we know that Jpa is just a standard specification or a standard API, and it doesn't have any implementation, right? And there should be an implementation for Jpa APIs. Well, Spring Data JPA it internally by default uses Hibernate as a Jpa implementation or Jpa provider. So in this case, consider we are using Hibernate as a Jpa implementation. Alright, so Jpa API internally call Hibernate core APIs, and then Hibernate will basically generate the SQL queries based on the method call. For example, let's say we want to persist an object into a database table. Then Hibernate will create the insert SQL query, and then it will internally call JDBC basic APIs, and then JDBC basic API will internally talk with the database. Okay, so this is how the flow goes. Service layer will call Spring Data JPA repository methods, and it will pass the required parameters. And then Spring Data JPA internally uses Jpa APIs, and it will pass the required parameters. And Jpa API internally call Hibernate core APIs, and it will pass the required parameters. And then Hibernate core API will generate the SQL query based on the method call, and it will bind all the values. And then Hibernate core API internally use JDBC APIs to talk with the database. Alright, so notice here Hibernate internally uses JDBC to talk with the database and execute the SQL queries. Alright, this is how the flow goes whenever we perform any database operation using Spring Data JPA. And if you can notice here, Spring Data JPA is just an abstraction layer on top of JPA to reduce the boilerplate code. Okay, and Spring Data JPA internally uses Jpa APIs and Hibernate implementation. Okay, so it means that Spring Data JPA is just abstraction layer on top of JPA to reduce a boilerplate code. Alright, I hope you pretty much understood the basic flow of Spring Data JPA. Alright, I will see you in next lecture. Hi, welcome back. In this lecture, let's quickly take a look into the difference between Hibernate and Spring Data JPA. Well, Hibernate is basically an implementation of JPA specification. Well, JPA is just a specification or a standard API that facilitates object relational mapping to manage relational data in a Java applications. Well, in Java, JPA basically provides object relational mapping feature. Okay, it means that instead of creating the SQL statements, we can directly persist an object into a relational database table using JPA. Okay, and JPA is just a specification. It don't have any implementation, right? So that is where the Hibernate comes into picture. Hibernate is basically a ORM framework that implements JPA specification. Okay, so Hibernate is a JPA implementation provider. Alright, on the other hand, if you can see Spring Data JPA, well, Spring Data JPA is abstraction layer on top of JPA to reduce the amount of boilerplate code required to implement DAO layer. Okay, so Spring Data JPA is nothing but it is an abstraction layer developed on top of JPA to reduce the amount of boilerplate code that is required to implement the data access object. Alright, so Spring Data JPA internally uses JPA APIs, and Hibernate basically implements JPA APIs. And if you can see here, Hibernate internally uses JDBC to communicate with the database. This is how the basically flow goes. Spring Data JPA internally uses JPA APIs, and Hibernate it implements JPA APIs, and Hibernate internally uses JDBC to communicate with the database. Well, let me summarize the difference between Hibernate and Spring Data JPA. Well, Hibernate is a Java-based ORM tool that provides a framework for mapping application domain model objects to the relational database tables and vice versa. Well, if we use the Hibernate ORM framework, then we don't have to create the SQL statement to perform different operations like Crude operations, basically like insert operations, select, delete and update, right? So Hibernate, it basically behind the scene generate SQL statement, and it will use the JDBC to communicate with the database. We don't have to create the SQL statement if we use Hibernate ORM framework, right? So we can use a Hibernate framework to directly map application domain model objects to the relational database tables. It means that we can use a Hibernate to directly persist an object into a relational database table. Alright, we don't have to create the SQL statements. Well, on the other hand, Spring Data JPA is an abstraction layer on top of JPA to reduce the amount of boilerplate code required to implement DAO layer. Well, Spring framework basically provides Spring Data JPA module, which is developed on top of JPA to reduce the amount of boilerplate code required to implement data access object layer. Well, Spring Data JPA minimizes a lot of boilerplate code, guys. We just have to extend Spring Data JPA provided a repository interface. That's it. We will get a full Crude operations And Spring Data JPA provides out-of-the-box implementation for all the Crude operations. Hibernate is a JPA provider. It means Hibernate, it implements JPA specification. On the other hand, Spring Data JPA is not a JPA provider. Spring Data JPA, it simply hides the JPA behind its repository abstraction. It means that Spring Data JPA, it is developed as abstraction layer on top JPA to reduce the boilerplate code required to implement DAO layer. Alright. Well, Spring Data JPA uses Hibernate as a default JPA provider. Well, Spring Boot offers a starter dependency to use Spring Data JPA in a Spring Boot project. And Spring Boot starter data JPA dependency, it internally uses Hibernate as a default JPA provider for Spring Data JPA. Spring Data JPA cannot work without a JPA provider. Well, there can be a multiple JPA providers, for example, Hibernate, Eclipse Link, Top Link, MyBetties. Okay, so there are a lot of implementations for JPA specification, right? And Spring Data JPA cannot work without JPA provider. You have to provide one of the JPA provider in order to work with Spring Data JPA. You can use Hibernate, or you can use Eclipse Link, you can use MyBetties, you can use Top Link. Okay, you have to use one of the JPA provider in order to work with Spring Data JPA. Alright, so this is the difference between Hibernate and Spring Data JPA. Alright, I will see you in next lecture. Hi, welcome back. In this lecture, we'll create a Spring Boot project using Spring Initializer, and then we'll import that Spring Boot project in IntelliJ IDEA. Well, let's open your favorite browser. I have opened Chrome browser over here, and just type start.spring.io. This will bring up Spring Initializer website. Well, Spring Initializer is basically a web tool that we can use to quickly create Spring based applications. Alright, now let's go and let's fill up all the project related information. Well, let's keep project as Maven project here as selected, and language Java. So you have a couple of options like Java, Kotlin, Groovy. We are going to use Java, so let's keep Java as selected over here. And here we need to basically choose a Spring Boot version, and by default 2.6.3 is selected. Okay, so this is basically recommended by Spring Boot team, so let's keep this stable and latest version of Spring Boot as it is. Alright, and this may be different in your case. As of now it is 2.6.3, but when you create your Spring Boot project, that time this version may different. Now let's go ahead and let's fill up the project metadata over here. Let's give group as something like com.springdata.jpa. Alright, and artifact ID, let's go and let's give Spring Data JPA course, and the project name is same as artifact. And demo, let's go and let's give something like Spring Data JPA with Spring Boot. Alright, and package name, let's keep com.springdata.jpa.spring-boot. Alright, and here packaging, let's keep jar as a selected, and Java version 11. You can choose Java 17 or 8 as per the Java installation on your machine, but as of now I'm going to keep Java 11 as selected as it is. Now let's go ahead and let's select the dependencies. Go ahead and click on add dependencies over here, and just type Spring Data JPA. Well, Spring Data JPA is a starter dependency provided by Spring Boot team, and this Spring Data JPA starter dependency include all the required libraries to develop the persistence layer or the DAO layer. Alright, and Spring Data JPA by default uses Hibernate as a JPA implementation. Okay, basically we use Spring Data JPA to reduce a lot of boilerplate code that is required to develop the DAO layer. Alright, so go ahead and select Spring Data JPA dependency. We'll explore more about Spring Data JPA starter dependency in the next lecture. Now go ahead and select one more dependency, that is MySQL driver. So in this course we are going to use MySQL database. So let's go and let's use MySQL driver Java dependency. So this dependency we basically use to connect our Spring Boot application with MySQL Server. Well, Spring Data JPA and MySQL Driver, these two dependencies are enough as of now, and you can explore this Spring Boot structure by using Explore option over here. Just go ahead and click on Explore, and you can see the dependencies in a pom.xml. For example, click on pom.xml over here, and you can see Spring Boot Starter Data JPA dependency and MySQL connector Java dependency. So these are the two dependencies we have added, and by default Spring Boot Starter Test dependency is added by Spring Initializer. So whenever you create a Spring Boot application using Spring Initializer, then this Spring Boot Starter Test dependency by default included in the pom.xml file. Alright, so go ahead and close it. Once you are happy with all these details, go ahead and click on Generate to generate this Spring Boot application as a zip file. So I am going to click on Generate over here, and this will basically generate a Spring Boot application as a zip file, and it will download in the file system. Now let's go and let's open this zip file in the file system. And as this is the zip file, let's go and let's extract it. Alright, now let's open the IntelliJ IDEA and let's import this project. So I'm going to open the IntelliJ IDEA over here, and you can see open option. So go ahead and click on open option here, and just go to the location where your Spring Boot application is downloaded. So in my case, I go to downloads folder, and then Spring Data JPA course project I have just selected over here, and click on open. So this will basically import Spring Boot application in the IntelliJ IDEA. Well, basically IntelliJ IDEA will take a couple of seconds to import Spring Boot project successfully, because it need to download all the dependencies and it need to set up the application properly. Alright, so you can see here resolving dependencies. Let's wait a couple of seconds. Alright, our Spring Boot application is successfully imported in the IntelliJ IDEA. Just you can go ahead and expand this project, and you can able to see this is the Spring Boot main entry point class, and you can run your Spring Boot application using this main entry point class. Alright, and if you can open pom.xml, and you can see Spring Boot Starter Data JPA dependency. Well, we'll explore more about this dependency in the next lecture. And you can go to the external libraries over here. You can see all the libraries are added in the class path. Alright, well, let me recap what we have done in this lecture. We have basically created a Spring Boot application using Spring Initializer, and then we have imported in a IntelliJ IDEA. In next lecture, we'll explore more about Spring Boot Starter Data JPA dependency. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, let's go ahead and let's explore more about Spring Boot Starter Data JPA dependency. Well, let's first understand what is the problem the developer were facing and what solution this starter dependency offers. Well, consider we are developing a Spring Boot application without using this starter dependency. Then what basically we need to do is we need to add a lot of dependencies. For example, we need to add Jpa dependencies, Hibernate dependencies, Spring Data JPA dependencies. Along with that, we need to add a couple of Spring dependencies as well, right? And as a developer, we need to also manage the compatible versions of all these dependencies. Okay, that is where the problem, developer need to manage all these things. Developer need to add all the required libraries to develop the persistence layer, the repository layer, and developer need to manage all the compatible versions of all these libraries, right? So that is where this starter dependency were introduced. So Spring Boot team basically created this starter dependency, and this starter dependency internally manage all these libraries and its compatible versions. We don't have to add a lot of libraries like Jpa dependencies or Hibernate or Spring Data JPA or Spring based dependencies, and yeah, so we don't need to add all these libraries. We don't need to manage all the compatible versions of these libraries. This starter dependency will take care of adding all the dependencies internally and managing the all compatible versions, right? So that is awesome, right? we just need to add one starter dependency, and it will include all the required libraries or the dependencies to develop the persistence layer or the repository layer, right? So this is basically one stop shop for all the libraries to develop the repository layer or the persistence layer. Okay, now what we're going to do is we're going to deep dive into this dependency, and we'll see what this dependency internally provides. Okay, let me go ahead and let me deep dive into this dependency, and you can able to see here this starter dependency internally added Spring Data JPA dependency. Okay, and it has already managed the version of this dependency, and along with that this starter dependency also added Spring Framework dependencies, Spring aspects. Okay, and you can see here this starter dependency also added Spring AOP dependency for managing the transactions, and this starter dependency also provides Spring Boot starter JDBC dependency internally. And look at here couple of Jpa dependencies. Okay, Jakarta Persistence API. Well, basically the name has changed from Java Persistence API to Jakarta Persistence API, and you can see here Hibernate dependency. Alright, so this starter dependency will basically include all these required dependencies to develop the persistence layer or the DAO layer. So this is awesome, right? We don't have to add all these required dependencies and manage its compatible versions. So this single starter dependency will take care of adding all the libraries internally and manage the compatible versions. Okay, so whenever you want to develop the persistence layer or the repository layer for any relational databases, then you can go ahead and use Spring Boot starter data JPA dependency. Okay, and whenever you add this starter dependency, make sure that you also need to add the JDBC driver. For example, in our case, MySQL connector Java. Make sure that you add JDBC driver dependency whenever you use Spring Boot starter data JPA dependency in your Spring Boot application. Okay, great. So this is a quick overview of Spring Boot starter data JPA dependency. In next lecture, we will configure MySQL database in our Spring Boot application so that we can able to connect our Spring Boot application with MySQL server. Alright, I will see you in the next lecture. Hi, welcome back. In previous lecture, we had a quick overview of Spring Boot starter data JPA dependency. In this lecture, we are going to connect our Spring Boot application with the MySQL database. Well, in order to connect our Spring Boot application with the MySQL database, we need to configure few of the properties. For example, we need to configure JDBC URL, MySQL database username and password, and couple of Hibernate properties. Well, let's go and let's open application.properties file in our Spring Boot application. Okay, and before configuring MySQL details in our Spring Boot application, first we have to create a database. Well, in order to create a database, we are going to use Mysql Workbench. Well, let me head over to the Mysql Workbench, and here just type the SQL statement create database, and we are going to give a database name something like e-commerce. Okay, and go ahead and execute this SQL statement. Alright, and go ahead and just refresh the schemas, and you can able to see e-commerce database is created. Okay, now we are good to configure this database in our Spring Boot application. Well, let's go to IntelliJ IDEA and open application.properties file, and here just type the property spring.datasource.url. So let's go and let's give the JDBC URL here, JDBC :MySQL. So this is a JDBC URL to connect to the MySQL database, followed by localhost. So we are going to connect our Spring Boot application with the local MySQL database. That's the reason localhost, followed by port 3306 is the default port of MySQL server, followed by database name, in our case e-commerce, and we are not going to use SSL connection, so let's use SSL equal to false to just disable the SSL connection. Similarly, let's go and let's configure username and password. Spring.datasource.username, in my case MySQL server username is root, And similarly, let's configure password equal to mysql@123. so make sure that you have to change username and password as per the MySQL installation in your machine. Alright, now we have configured JDBC URL, username and password. And one more very important point here is we don't have to add driver class name here, because Spring Boot will automatically detect the driver class name as per the driver dependencies in a pom.xml. For example, in our case, you can see here we have added MySQL connector Java driver dependency, right? Spring Boot will automatically add a driver class name by looking into this dependency in the pom.xml. Alright, we don't have to add a driver class name here. Okay, now what we're going to do is we're going to add Hibernate Dialect. Alright, so let's go and let's type the property spring.jpa.properties and then .hibernate.dialect equal to, this is the MySQL InnoDB dialect. Alright, so make sure that whatever the database you are using, for example in our case we are using MySQL database, right? And we have to add MySQL Hibernate Dialect like this. Okay, so basically Hibernate will create the SQLs based on the dialect that we add in our Spring Boot application. In our case we are adding MySQL Hibernate Dialect, right? So Hibernate will basically create a SQL queries with respect to the MySQL database. Let's say if you are using other databases like PostgreSQL database, then you have to add PostgreSQL Hibernate Dialect. So Hibernate will basically use the PostgreSQL dialect to create the SQL queries based on the database vendor. Okay, so in our case we are using MySQL database vendor, so Hibernate will generate SQLs behind the scene with respect to the MySQL database vendor. Now let's go and let's add one more Hibernate property, that is auto Ddl property. Just type the property here, spring.jpa.hibernate.auto Ddl, and here basically we have a couple of options for creating the database schema generation. Well, Hibernate basically provides a lot of options over here. For example, you can see none, create only, drop, create, drop, validate, update. So these are the possible options for for this property. Alright, so basically Hibernate provides these values or the property options to customize the Hibernate data schema generation process. Well, let me explain you all these possible options so that you will understand better. Let's say if you use none here, none value for this property, then this none option basically disable the auto Ddl tool, which means that Hibernate is not going to take any action for managing the underlying database schemas. Okay, Hibernate is not going to create a database tables for you. You have to manually execute all the database tables manually in the MySQL database. Okay, so this will basically disable the Hibernate auto Ddl tool. Okay, tool meaning Hibernate will basically provides a tool to generate the database tables behind the scene for us, right? So this option will basically disable that tool. Alright, and second is create only. Let's say if you use create only value, then this option basically tells Hibernate that Hibernate have to generate a database schema from the entity model. Well, whatever the Jpa entity models that we are going to create in our Spring Boot application, this option tells Hibernate that create all the tables for all the Jpa models that we create in the Spring Boot application. Okay, next comes drop. Well, basically drop option tells Hibernate to drop the database schemas using entity model as a reference for the Ddl drop statements. Well, this option tells Hibernate to drop all the tables by just referring the Jpa entities or the models that we create in our Spring Boot application. Okay, so this will basically instruct Hibernate that just drop all the tables by referring the JPA models that we created in our Spring Boot application. Pretty simple. Well, the next option is create. Okay, create. Well, this create option basically tells Hibernate that drop the existing database schema and recreate all the tables by referring the JPA models that we create in a Spring Boot application. Okay, so this option basically tells Hibernate to recreate all the database tables by referring the JPA models that we create in our Spring Boot application. Well, next is create hyphen drop. So this option or value basically tells Hibernate that drop the existing database schema and recreate all the database schema tables, and once the entity manage factory or the Hibernate session factory close, then again drop all the database tables. Okay, so this will tell Hibernate that drop the existing database schema and recreate all the database schema tables, and once the entity manager factory or the Hibernate session factory close, then again drop all the existing database schema tables. All right. Well, the next is validate. Well, validate option tells Hibernate that just validate the underlying database schema against the entity mappings. So this value just tells Hibernate that just validate the underlying database with the entity mappings that we have done in the Spring Boot application. Well, next value is update. Well, update option tells Hibernate that basically update the existing schemas with whatever the changes we have done in the Jpa entities. Alright, and in this course most of the time we are going to use update value because it won't drop the existing tables. It simply alter the table whatever the changes we do in a Jpa entities. Okay, so this is pretty useful property while development, so we are going to use update as a value for this property in this course. Okay, I hope you understood all these possible options for this auto DDL Hibernate properties. Now what we're going to do is we're going to add a couple of more Hibernate properties to just see the SQL statements that Hibernate generate behind the scene, and also the SQL statement should be well formatted. For that I'm going to add a couple of properties here. For example, spring.jpa.showSQL equal to true. So this will basically show all the SQL statement that Hibernate create behind the scene, and spring.jpa.properties.hibernate.format_SQL equal to true. So all the SQL statement that Hibernate create behind the scenes should be well formatted. Okay, great. Well, that is pretty much it. We have configured all the MySQL configuration in our Spring Boot application. Now let's go and let's verify whether our Spring Boot application will connect with a MySQL database, that is e-commerce database, or not. Well, here we basically made a small typo, so this should be Ddl -auto. So make sure that the property name should be correct. Now what we're going to do is we're going to run our Spring Boot application and we'll see whether our Spring Boot application will able to connect to the MySQL database or not. In order to do that, let's go and let's run our Spring Boot project. We'll go to the Spring Boot main entry point class here and let's run the Spring Boot project, and there we go. There are no exceptions, no errors in the console. It means that our Spring Boot application is successfully connected with the MySQL database, and you can able to see the logs in the console like Hibernate is using MySQL for you InnoDB Dialect, and by default Spring Boot uses Hikari as a connection pool. You can able to see that Hikari data source. Okay, Spring Boot auto configure this connection pool by default. Well, let me recap what we have done in this lecture. We have configured MySQL details in application.properties file, and we have gone through all these Hibernate Ddl auto property values, and we ran our Spring Boot application, and we can able to see that our Spring Boot application has successfully connected with the MySQL database. Well, in next lecture we are going to see how we can create a Jpa entity and how we can map our Jpa entity to the relational database table. Alright, Great, I will see you in next lecture. Hi, welcome back. In previous lecture, we have seen how to connect our Spring Boot application with the MySQL database. Well, in this lecture, we are going to create a Jpa entity and we'll see how to map Jpa entity to the relational database table. Alright, so first of all, we are going to create a packaging structure for our Spring Boot application. So head over to the main package, right click, new, and then choose package, and let's give package name as entity. Well, different developers prefer using different naming conventions. For example, here we are using entity, but some of the developers may use a model package to keep all the Jpa entities, or some of the developers may use a domain package to keep all the Jpa entities. Well, in this course we are going to use entity package. Okay, great. Now let's go and let's create one more package and let's call it as repository. Well, within a repository package, we are going to keep all the Spring Data JPA repositories. Perfect. Now let's go and let's see how to create a JPA entity. Well, we are going to basically create a product JPA entity. Okay, so go to the entity package, right click on it, new, and then choose Java class. Let's go and let's give class name as product. Hit enter. Now we are going to define the private instance variables. Well, let's say private and then long id, private string skew. So this is basically a stock keeping unit, and this is a short form for stock keeping unit. Okay, and then private string product name. All right, and private string product description. Let's call it as a description. Perfect. And private, and let's have a price for the product. We are going to use big decimal. Okay, big decimal, and let's say price, and then private, and let's use a boolean whether a product is active or not, that is active field. And then let's go and let's use one more field, that is, let's say, image URL. And let's go and let's create a couple of more fields like date created. Okay, and then one more field, updated date, or we can say last updated. Okay, perfect. So to keep it simple, these are the fields for product class. So go ahead and create a getter setter methods to access these private fields. Well, right click inside this class and then choose generate, and then choose getter and setter, and select all these fields and click on OK. Now we have created a getter setter methods to access these private fields. Okay, and if you can closely observe this class, this is the Pojo class. Basically, Pojo meaning plain old Java object. Now let's go and let's make this Java class or a Pojo class as a Jpa entity. Well, in order to make this Pojo class as a Jpa entity, we have to use Jpa Annotations. Well, there is one annotation, that is @entity annotation, and this @entity annotation from javax.persistence package. Alright, so we basically use this annotation to specify this class as a Jpa entity. Well, you can read the description like here. Okay, so this entity annotation specifies that the class is an entity, and this annotation is applied to the entity class. Well, whenever you want to make a Pojo Java class as a Jpa entity, then you have to use this @entity annotation, and make sure that you use @entity annotation at a class level. You cannot use this @entity annotation at a field level. Now we have made this product class as a Jpa entity. Well, in order to map this product Jpa entity to the relational database table, we have to also create a primary key. So in order to create a primary key for this product Jpa entity, we are going to use @id annotation, and make sure that @id annotation from javax.persistence package. Now we have created a product Jpa Entity by using these Jpa annotations. Well, let's go and let's run our Spring Boot application and let's see how Hibernate will automatically create a table for this Jpa Entity. Alright, and if you can open application.properties file over here, you can see this property. Well, this is the Hibernate property which is responsible to automatically create a table for the Jpa Entity. Alright, let's go and let's run the Spring Boot application and let's explore more about how Hibernate will create tables for Jpa Entity. Well, look at here in a console, you can able to see Hibernate generated SQL DDL script to create a product table, and by default Hibernate provide a table name as a product. For example, if you can see the Jpa Entity, so Hibernate will by default provide a table name as a product. Okay, and we have to customize the table name, right? So in next lecture we'll see how to use Jpa Annotations to customize this table structure. Okay, and again you can see Hibernate uses the default column naming conventions like this. For example, you can see here date created, so this is the field, right? And you can see the column name date underscore created. Okay, so this is how the column name by default Hibernate will create for this this kind of field names. Okay, date created, so whenever the field has two words like date created, then Hibernate will provide an underscore between these two words. Okay, so this name for column makes sense, right? That's why Hibernate uses this naming convention to provide a column name for this kind of fields. Now let's go to database and let's see whether table is created or not. Let me refresh the schemas and you can able to see under tables you can see product table is created. Okay, and you can see all the columns. Alright, so this is how Hibernate will create a SQL statement behind the scene to create a product table for product Jpa Entity, and this is how Hibernate uses naming conventions for table and columns. Okay, and again we need to customize this table a lot using Jpa Annotations. For instance, if you want to give a different name to the table, okay, then Jpa provide one more annotation, that is add table annotation, we can use to customize the table name. And let's say if you want to give different name to the column, well, Jpa again provides add column annotation to customize the column column name and column attributes. Okay, and let's say if you want to make one of the column as a unique constraint, then you can go ahead and use add unique constraint annotations. Okay, in next lecture we'll see how to use all these Jpa annotations to customize this table structure. Okay, great. I will see you in next lecture. Hi, welcome back. In previous lecture we have created a product Jpa Entity and we have seen how Hibernate will create a Ddl SQL script behind the scene to create product database table. And look at here, Hibernate basically uses default naming convention to provide a database table name and default column names to the fields, right? For example, look at here, this is the Hibernate generated SQL DDL script to create the product table in the database, and Hibernate by default provided a table name as a product. And if you can see the Jpa Entity, that is product Jpa Entity, we haven't provided a table name to this product Jpa Entity, right? By default Hibernate provided table name to this product Jpa Entity as a product. It will just lowercase the post character. Okay, and Hibernate provided these default naming conventions for columns for these fields, right? And we need to customize this table a lot. For instance, we need to give a proper name to the table, and we also need to provide a unique constraint to these columns. For example, let's say if we want to provide a unique constraint to this stock keeping unit column, then we need to use the Jpa annotations. And let's say if we want to provide primary key generation strategy, like we want to auto increment the ID, or we need to provide a sequence to create a primary key, right? And we need to provide a size for the columns, right? So in order to customize the table details or table structure, we have to use Jpa annotations. Alright, so in this lecture, let's see how to use Jpa annotations to customize the table structure. So in order to configure table details for this product Jpa entity, we can use add table annotation from javax.persistence package. So now we can give a name to the table. For example, add table annotation has a different attributes. So let's go and let's use name attribute, and let's give name to the table. For instance, different developers prefer giving different naming convention for the tables, right? Let's say some of the developer give a table naming conventions like this, table underscore products, okay? Or some of the developers prefer using a plural form of the entity like products. Okay, so to keep it simple, I will give products as a table name. So along with a table name, you can also provide a schema here itself. For example, I'm going to use schema attribute, and then I can define schema. For example, our schema is e-commerce, right? Schema or database. So let me copy this and I can simply paste it here. So in this way, you can also configure schema or database for this product Jpa entity. Alright, great. Now let me quickly format this. Perfect. Now let's go and let's see how to define a unique constraint for a columns. Alright, so let's say in product Jpa entity, we are going to make this stock keeping unit column as a unique constraint. So in order to define a unique constraint for this column, we're gonna use unique constraints attribute of this annotation. So you can see add table annotation has an attribute called unique constraints. Okay, so go ahead and use this unique constraint over here, and within a unique constraints we can define a multiple unique constraints for multiple columns. Okay, so now I'm going to use add unique constraint annotation to define a unique constraint for stock keeping unit column. Okay, so this annotation has two attributes, name and column names. So let's go ahead and let's use name field to provide a name to the unique constraint. So let's say stock keeping unit unique. Okay, and also provide a column name to which this unique constraints applies. So in our case, the column name is SKU. Okay, stock keeping unit. All right, perfect. So this should be unique, right? Perfect. So this is how we basically make a column as a unique constraint by using add table annotation. Okay, perfect. If you want to make other columns as a unique constraint, then you can go ahead and use add unique constraint annotation like this. Okay, just use name here, and let's say if we want to give a unique constraint for product name, so you can go ahead and say name unique and also define the column name. Okay, column name is name like this. Okay, so to keep it simple, I'm going to define a unique constraint for stock keeping unit column. Okay, perfect. So this is how we define a unique constraint for columns in a Jpa entity. All right, now I'm going to show you how we can customize the column for the fields. Let's say we want to change a column name. I mean, we want to give a different name to the columns. For instance, let's say I want to give column name for this stock keeping unit like this. For instance, I'm going to use add column annotation and name, and then let's say I want to give different column name, something like stock keeping underscore unit. Alright, so in order to customize the column name and column details, we can use add column annotation. Alright, so add column annotation specifies the mapped column for the persistent property or a field. If no column annotation is specified, the default values applied, and by default we have seen like Hibernate provides a default name to the columns as a field name. Okay, now we have changed a column name for this stock keeping unit, so I can copy this and I can give column name here. Okay, great. Now we can also define this column as a not null. For that we have property null label equal to false. Okay, and if you want to make a product name column as a not null, then simply you can use add column annotation and you can simply pass null label equal to false. So this will basically make this column as a not null. Okay, perfect. So this is how we basically customize a column for the field. Alright, great. Well, you can also mention the size or length for the column. For instance, add column annotation has a attribute called length. You can use a length attribute to define the size. By default it is 255. Alright, so let's keep default as it is. Now let's go and let's see how we can use a primary key generation strategies to create a primary key for the row in the table. Well, JPA or Hibernate basically provides 4 types of primary key generation strategies. Well, in next lecture we will go through these 4 types of primary key generation strategies, but in this lecture I am going to use identity as a primary key generation strategy. Well, in order to define a primary key generation strategy, we have to use add generated value annotation, and make sure that you choose add generated value annotation from javax.persistence package, and this add generated value annotation has attribute called strategy. Okay, go ahead and use strategy attribute and then simply type generation type and identity. Well, basically JPA provides 4 types of primary key generation strategy: auto, identity, table and sequence. In next lecture we will see these 4 primary key generation strategy. As of now, let's use identity. Well, identity will basically auto increment the table column in the database. Now we have pretty much customized the product Jpa entity. Alright, now let's go and let's run our Spring Boot application and let's see how Hibernate will create a table for this Jpa entity. Well, I am going to run Spring Boot application now. Okay, and let's see how Hibernate will generate a SQL Ddl script behind the scene for this products table. And you can see here Hibernate generated Ddl script, and let me compare with product Jpa entity. Well, you can see table name products, and we have configured table name as a products. And next you can see primary key generation strategy, we have provided identity, and this should be auto increment. You can see in a Ddl script auto increment, and you can see we have customized the column for stock keeping unit, and you can able to see the column name is changed from SKU to stock keeping unit, and you can see here not null because we have provided null label equal to false, right? And again you can see we have provided unique constraint for stock keeping unit, right? That we can see a little bit below. Yeah, here you can see Hibernate basically generated the alter SQL statement, alter table products, add constraint, stock keeping unit. Okay, and this is the basically a unique constraint name that we have provided over here. All right, great. So this is how basically we use Jpa annotations to customize the table structure. Okay, as per our requirement we can provide a table name, column name, and we can provide a size for the column. We can define the unique constraint. Okay, we can define the primary key generation strategy. All right, great. Now let's head over to the database and let's verify whether this table is created or not. I'm going to head over to the Mysql Workbench and I'm going to refresh the schemas, and you can see products table is created. Okay, and you can see all the columns and stock keeping unit. So this column has changed, right? And this product table it was already created in one of the previous lecture. So I'm going to drop this table. Perfect. Now we have products table in our database. Alright, great. Well, in next lecture we will see 4 types of JPA provided primary key generation strategies. Alright, so this is very important. So let's discuss in the next lecture. Alright, I will see you in next lecture. Hi, welcome back. In previous lecture, we have seen how to use Jpa Annotations to customize the table structure, right? In this lecture, we'll see 4 types of JPA provided primary key generation strategies. Well, basically Jpa specification supports 4 different primary key generation strategies that generate the primary key values programmatically or use database features like auto-incremented columns or sequences. Okay, and here are the 4 primary key generation strategies like auto, identity, sequence, and table. Let's discuss each of these primary key generation strategies one by one. Well, let's first take a look into generation type auto. Well, generation type auto is a default generation type and it lets the persistence provider choose the generation strategy. Well, whenever we specify generation type as auto, then this value will let the persistence provider or the database vendor to choose the generation strategy. Okay, and in order to specify generation type auto, we have to use at generated value annotation. So you can see here code snippet. We are using at generated value annotation and it has the attribute strategy, and we can specify generation type auto as a value to the strategy attribute. Okay, and if you are using Hibernate as a JPA implementation or the JPA persistence provider, then Hibernate will basically select the generation type based on the database specific dialect. Well, most of the popular relational databases like PostgreSQL database, Oracle database, Mysql database, so these databases uses sequences to generate a primary keys for the tables, right? So Hibernate will basically use or select the primary key generation strategy based on the database specific dialect, and most of the time Hibernate use a generation type sequence as a primary key generation strategy, because most of the relational databases, especially popular relational databases like PostgreSQL database, Oracle, MySQL, so all these relational databases support the sequences. So Hibernate will most of the time uses sequence as a primary key generation strategy. Now let's go and let's see how to use a generation type auto in our product Jpa entity, and how Hibernate will behind the scene uses a generation strategy as a sequence in our project. Well, let's head over to the IntelliJ IDEA, and here we have used identity as a primary key generation strategy. So now we are going to replace from identity to auto. Okay, great. Now I want to run the Spring Boot application and we'll see how Hibernate will use a sequence as a generation strategy. Let's go and let's run the Spring Boot application. So look at here in a console, Hibernate basically created one more table called Hibernate underscore sequence. So this is the default name. Okay, so each time we insert a record in the table, then Hibernate will get the value from this table and it will increment it and it will again insert that one. Okay, so basically Hibernate will use this Hibernate underscore sequence table to maintain a sequences for the primary keys for the table. All right, and MySQL database, it doesn't have a sequence mechanism. That's why Hibernate created a separate table to maintain the sequences. But if you use the other relational databases like PostgreSQL database or Oracle databases, so these databases have their own sequence mechanism. Okay, so in this case we are using MySQL database, so Hibernate will create a new database table to maintain the sequences. Alright, now if you can head over to the MySQL Workbench and refresh the schemas, and you can able to see Hibernate underscore sequence, a table is created to maintain the sequence for the primary keys. Okay, so this is how we can use a generation type auto to provide a primary key generation strategy. Okay, so this will basically let the persistence provider to select the primary key generation strategy, and we are using Hibernate. So Hibernate most of the time use sequence as a primary key generation strategy. Alright, I hope you understood how to use a generation type auto. Well, the next is generation type identity. Well, this basically relies on the auto incremented database column and lets the database generate a new value to each insertion operation. Well, probably you are familiar with auto increment database column, right? So this is the SQL Ddl script property, auto increment. So each time we insert a new row in the database, then database basically auto increment a primary key value, right? So we can do that by using generation type identity. So in order to specify generation type identity, we simply pass a generation type dot identity as a value to the strategy attribute of at generated value annotation. Okay, and from database point of view, this is a very efficient because the auto increment columns are highly optimized and it does not require any additional statements. Well, identity primary key generation strategy has some drawbacks if we use Hibernate. For instance, Hibernate will immediately create the primary key and then it will insert the record in the database, right? And this is not good for JDBC batch operations. And if you are not using JDBC batch operations in your project, then you can go ahead and use identity as a primary key generation strategy. Alright, now let's go and let's see how to use this identity primary key generation strategy in our product Jpa entity. Well, let me head over to the IntelliJ idea and let me replace from auto to identity. Now what I will do, I will simply drop the tables. Okay, so I'm going to drop these two tables because I want to see how this works. Okay, how this identity primary key generation strategy works. Alright, now let me run the Spring Boot application and let's see how Hibernate will create a table and primary key for the products table. Well, look at here, Hibernate basically created these SQL statement behind the scene. And for identity primary key strategy, Hibernate added auto increment as a primary key generation strategy. Alright, and this auto increment is basically done by the database will basically create a new value and it will add as a primary key in the table, isn't it? So just remember, identity primary key generation strategy, it relies on the auto incremented value of the column. Well, the next primary key generation strategy is sequence. Well, sequence is the most commonly used primary key generation strategy in a large applications. Alright, and I'm going to suggest you to use a sequence as a primary key generation strategy if your application is huge. Alright, and you can see here we can specify sequence as a primary key generation strategy using at generated value annotation and at sequence generator annotation. Well, we can use at sequence generated annotation to specify the sequence name along with that allocation size. Well, here allocation size equal to 1, meaning the sequence can increment by 1. Alright, and by default allocation size is 50. And once we generate the sequence, we can provide its reference in an at generated value annotation. For example, here look at here, at sequence generator has a name product underscore generator, and this name we should give here, okay, in an at generated value annotation. Alright, we'll see in an example how we can use it. And sequence primary key generation strategy basically uses additional select statement to get the next value from the database sequence, but this has no performance impact on most of the applications. Alright, and most of the relational databases supports a sequence. For example, PostgreSQL database, Oracle database, Mysql database. Alright, so let's go and let's see how to use sequence as a primary key generation strategy in our product Jpa entity. Well, let me head over to the IntelliJ idea and let me first of all drop the tables. Let me drop this products table first because we'll see how sequence primary key generation strategy works, right? Now what I'm going to do is I'm going to simply use sequence, okay, and we can use add sequence generator annotation to generate the sequence. Okay, so if you don't specify sequence by using this annotation, then Hibernate will by default create a sequence for you. All right, so here I'm going to provide a sequence, okay, as per my requirement. For example, let's say I want to give name to the sequence. For instance, let's use name here. So let me align properly. So let's use name to give name to the sequence. Let's say product generator, something like that, and let's give sequence name something like product underscore sequence underscore name, okay, and let's give allocation size. By default it is 50, so we can give 1. Okay, so here 1 meaning we will tell Hibernate that create a sequence by incrementing 1. Okay, and once we generate the sequence, now we need to provide a reference to the add generated value annotation. Okay, so this annotation has a generator attribute, okay, generator, and then simply pass this, okay, copy and paste it here. Okay, so this is how we basically create a sequence for this primary key. Okay, so we are basically using add sequence generator annotation to specify sequence manually. Okay, so if we don't specify this sequence, then Hibernate will create a default sequence table for us, right? And here basically we are explicitly specifying the sequence. Okay, the sequence name is this, and this is the name to this sequence to just provide a reference to this add generated value annotation here. All right, great. Now let's go and let's run the Spring Boot application and let's see how this works. So look at here, Hibernate basically created a lot of SQL statement. All right, let's go one by one. So this is the SQL statement to create the products table, and then this is the SQL statement to add a constraint, and you can see this table product underscore sequence underscore name. So this is the table the Hibernate created to maintain the sequences, and you can see in a product Jpa entity we have given a sequence name as product underscore sequence underscore name, right? And Hibernate will basically use this sequence name to create a new table to maintain the sequences. All right, great. Now let's head over to the Mysql Workbench and let's refresh the schemas, and you can able to see products and product underscore sequence underscore name. So these two tables are created, and this table is to maintain the sequences, and as of now you can see value 1. Well, each time we insert a new row in the product table, then Hibernate will trigger one more select query to get the value from this sequence table. Let's go and let's take a look into the next primary key generation strategy, that is table. Well, this primary key generation strategy is rarely used nowadays because it simulates a sequence by storing and updating its current value in the database table, which requires the use of pessimistic locks, which puts all the transactions into a sequential order, and this will basically slow down your application, and you should therefore prefer using sequence as your primary key generation strategy. All right, so table primary key generation strategy is rarely used nowadays. Okay, and Hibernate team basically suggest or recommend to use a sequence as a primary key generation strategy. Well, let's go and let's see how to use table as a primary key generation strategy in our product Jpa entity. Okay, so before that, let me go ahead and let me drop the tables so that we can see how the table primary key generation strategy works. All right, now I'm going to simply remove these lines of code, and also I'm going to remove this one, and I will simply specify generations type as a table. Perfect. Now let me run the Spring Boot application and let's see how this works. Well, look at here, Hibernate generated SQL statements. So this looks similar to sequence primary key generation strategy, but it uses different mechanism. That's why Hibernate don't recommend this approach. All right, so Hibernate recommend to use sequence as a primary key generation strategy. So let me simply undo it, and let's use a sequence as a primary key generation strategy. Alright, so these are the 4 primary key generation strategy that JPA specification supports. Alright, and we have seen all of them with live example. Alright, in next lecture what we'll do, we'll see how to use Hibernate provided few of the important annotation to populate date created and last updated values. Alright, I will see you in next lecture. Hi, welcome back. In this lecture, we'll see how to use Hibernate provided timestamp annotations to automatically populate the values for dates. So you can see here in our product Jpa Entity, we have a date created and last updated fields, right? And each time we create a product object, we have to specify the values for these fields, right? Well, tracking the date created and last updated database record is a common requirement, right? So instead of manually specifying the values for these fields, we can use Hibernate provided timestamp annotation to automatically assign values for these fields. Alright, so let me show you how we can do that. So let's go and let's use the Hibernate provided annotation, that is at creation timestamp annotation. So make sure that you choose creation timestamp annotation from Hibernate package. Okay, that is org.hibernate.annotations. So this annotation will basically automatically populate the value for this field. Okay, so this annotation will basically get the current time from the JVM and then it will assign to this field. Alright, next let's go and let's use at update timestamp annotation from org.hibernate.annotations package to automatically provide the timestamp value for this field. Well, once we add Hibernate provided timestamp annotations to these fields in a Jpa entity, then Hibernate will basically take care of the necessary updates. We don't have to manually add or track the values for these fields. Hibernate will automatically take care of updating these values for us. Okay, so these are the useful annotations we can simply use to just let Hibernate to manage the values for these fields. Alright, great. Now let's quickly run our Spring Boot application and let's verify these changes will work as expected. So let me run the Spring Boot application. And you can see there are no exceptions or the errors. It means whatever the changes we have done, it is working as expected. Alright, great. I will see you in next lecture. Hi, welcome back. In this lecture, we'll see how to use Lombok Library to reduce a boilerplate code. Well, Lombok Library is basically a popular Java library that helps us to reduce a boilerplate code. Here, boilerplate code meaning a getter setter methods, constructor, toString method, equals method. Okay, for example, consider a product Jpa entity here, and we have created a lot of getter setter methods, right? And look at here the lines of code. Okay, we have created these lines of code to just generate a getter setter methods. Alright, and let's say if we have too many Jpa entities, for example, in our e-commerce project, we can create a product Jpa entity, product category, order item, okay, user, roles, address, right? So if we create these Jpa entities, then obviously we need to create a getter setter methods to access the private fields, right? And sometimes we need to create a constructors, we need to create equals and hash code methods, toString methods, right? So this is basically a boilerplate code. We need to create this kind of code repeatedly, right? In order to reduce this kind of boilerplate code, we can use a Lombok library. Well, basically Lombok is a Java library which will help us to reduce this kind of boilerplate code. And you can see it provides a lot of annotations. Okay, for example, look at here, @getter, @setter annotations. So we can use these annotations to automatically generate getters and setters for the private fields. And @toString annotation we can use to generate a toString method for the class, and equals and hash code. And these are the couple of annotations to generate no argument constructor, required argument constructor, and all argument constructor. And if you want to have a builder pattern for your class, you can use @builder annotation. Alright, so let's go ahead and let's see how to use Lombok library in our Spring Boot application, and let's see how to reduce the boilerplate code. Well, first of all, let's get the Lombok dependency. So in order to get the Lombok dependency from the internet, so I'm going to head over to the start.spring.io. So this will head over to the Spring Initializer and go to add dependencies, and here just search for Lombok. Okay, and just choose the Lombok dependency. So this is basically Java annotation library which helps to reduce a boilerplate code. And go ahead and click on explore, and you can simply copy this Lombok dependency. Okay, and let's head over to the IntelliJ IDEA and go to pom.xml and just go here and just paste it. So as soon as you paste this dependency, you will get an icon here. Okay, so go ahead and click on this icon to load Maven changes. Alright, now we have added Lombok library to our Spring Boot application, and we are good to use Lombok annotations. So go back to product Jpa Entity, and here we are going to simply remove getters and setters. Alright, and just go ahead and annotate this class with @getter annotation and @setter annotation. And if you want to use no argument constructor or all argument constructor, then you can go ahead and use annotations like no argument constructor, meaning a default constructor, and all argument constructor, meaning a parameterized constructor. Okay, great. Now we have used a Lombok annotation to reduce the boilerplate code. So going forward, whenever we create a Jpa entities, we will be using Lombok annotation to reduce a boilerplate code. For example, getter setter methods, constructors, toString methods. Okay. Well, now let's go and let's run our Spring Boot application, and let's see these changes will work as expected. So I'm going to run the Spring Boot application. And look at here, there are no errors or exceptions in the console. It means that we have successfully used a Lombok library in our Spring Boot application. Alright, great. I will see you in next lecture. Hi, welcome back. In this lecture, we'll take a look into important repository interfaces, its relationships, and its implementations. Alright. So before looking into repository interfaces, let's first take a look into Spring Data Framework. Well, Spring Data Framework basically contains a lot of modules. For instance, Spring Data Commons, Spring Data LDAP, Spring Data MongoDB, Spring Data JPA, Spring Data JDBC, and there are a lot of other Spring Data modules. And if you look at the hierarchy over here, Spring Data Commons is the parent project, and the other projects like Spring Data LDAP, Spring Data MongoDB, Spring Data JPA, Spring Data JDBC. So these modules basically extends Spring Data Commons. Alright, so Spring Data Commons is basically contains all the common interfaces and classes, and the other modules like Spring Data LDAP, Spring Data MongoDB, Spring Data JPA, Spring Data JDBC. So these modules basically extends Spring Data Commons interfaces. Okay, so just remember, Spring Data Commons is the separate project, and it is basically a parent project. It contains all the common interfaces, and the other modules basically extends Spring Data Commons interfaces. Okay, and these Spring Data projects have their own purposes. For instance, Spring Data LDAP, it basically supports LDAP implementation. Spring Data MongoDB, it supports MongoDB based DAO layer. Spring Data JPA, it basically supports JPA related DAO layers, and Spring Data JDBC basically supports JDBC related DAO layer, right? So each project have their own purpose, and in this course we will be more focusing on Spring Data JPA. It basically support for JPA based data access layers. Well, once we understood Spring Data framework modules and its hierarchy, let's go back to our repository interfaces class diagram over here. And if you look at the class diagram, repository interface is basically a root interface, and Crude repository interface extends repository interface. Paging and sorting repository interface extends Crude repository interface, and query DSL predicate executor. So this interface is basically independent of these interfaces. Alright, and these four interfaces are belongs to Spring Data Commons module. And you can see here Jpa Repository Interface and Jpa Specification Executor Interface. So these two interfaces are belongs to Spring Data JPA module. And as we know that Spring Data JPA module, it extends Spring Data Commons module. So if you can see the interfaces, Jpa Repository Interface from Spring Data JPA module extends paging and sorting repository interface of Spring Data Commons module. Alright, this is how the repository interfaces hierarchy looks like. Jpa Repository Interface internally extends paging and sorting repository interface. Paging and sorting repository interface internally extends Crude repository interface, and Crude repository interface internally extends repository interface. Alright, so this is how the repository interfaces relationships looks like. Well, in this course we'll be more focusing on Jpa Repository Interface. So let's go ahead and let's learn more about Jpa Repository Interface. Well, Jpa Repository Interface, you can see here, it extends paging and sorting repository interface, and paging and sorting repository, it internally extends Crude repository interface, and Crude repository interface internally extends a repository interface. And Crude repository interface basically provides Crude methods. For example, save all, find by ID, find all, delete by ID, delete. Alright, so these are the Crude methods that Crude interface basically exposes. And paging and sorting repository interface, it provides a support for paging and sorting. Alright, so basically these two methods supports sorting and pagination. Apart from that, Jpa Repository Interface also exposes few of the methods which supports batch operations and other operations. For example, find by ID, find all with sort as a method argument, flush, save and flush, delete in batch, delete all in batch, okay, save all. So these are the few methods that Jpa Repository Interface also exposes. Well, in order to leverage all these methods, we simply create our own interface, for example product repository interface, and extends Jpa Repository Interface, and we need to simply pass entity name and the primary key type. That's it. Once we do this, we'll be able to leverage all these methods, right? This is awesome, right? We just have to create one interface and it extends Jpa Repository Interface and just pass entity name and the primary key type. That's it. We'll be able to leverage all these methods. We don't have to write any code. I mean, we don't have to write implementation class to implement this interface and a repository interface and its methods. Okay, Spring Data JPA internally provides implementation for all these methods. We don't have to write any code. We just simply need to create the interface and extends Jpa Repository Interface. That's it. We'll be able to get all these methods for entity. In this case, product is the Jpa entity. Alright, now you may have a question like, so far we have seen the repository interfaces and its methods, and where's the implementation? Who will be able to implement all these repository interfaces and its methods, right? So basically Spring Data JPA is responsible to implement all these methods. Basically Spring Data JPA provides simple Jpa repository class. It implements all these important methods. Okay, for example, look at here, Jpa repository implementation. Well, Spring Data JPA internally provides simple Jpa repository class which implements all the methods of Jpa Repository Interface. Okay, just remember, Spring Data JPA provides simple Jpa repository class. It is basically a default implementation class of Jpa Repository Interface. And simple Jpa repository class, it provides a transaction management for all its implementation methods, right? It means that all the methods of Jpa repository interfaces are by default transactional. We don't have to make these methods again transactional. For example, you can see simple Jpa repository class, it is annotated with @transactional annotation. It means that all the methods in a simple Jpa repository class are by default transactional. We don't have to again annotate these methods with @transactional annotation. Alright, well, in next lecture we'll deep dive into Spring Data JPA library and we'll understand these repository interfaces and its implementation classes. Alright, I will see you in next lecture. Hi, welcome back. In previous lecture, we have gone through some of the important repository interfaces, its relationships and its implementation classes at a high level. In this lecture, we'll deep dive into Spring Data JPA library and we'll understand more about these repository interfaces and its implementation classes. Alright, let's head over to the IntelliJ IDEA and let's deep dive into Spring Data JPA library. Well, basically we are going to decompile Spring Data JPA library, that is a jar file, and we will see its interfaces and implementation classes. Well, in order to see the Spring Data JPA jar file and its .class files, what we can do is we can go to the external libraries section over here, just expand it and go ahead and just search for Spring Data JPA library. For instance, you can see here, Spring Data JPA library. So go ahead and just expand it and then you can able to see Spring Data JPA jar file, right? And just go ahead and dive into this package and just go ahead and click on a repository package over here, and here you can able to see Jpa Repository Interface. Alright, so this is basically interface. Just go ahead and double click on it and you can able to see Jpa Repository Interface and it's all methods. Alright, so basically this is a .class file. Alright, so we have deep dive into jar file and we are looking into its interfaces and classes. So you can see Jpa repository is the interface and it internally extends paging and sorting repository interface. So just press Ctrl and click on this and you can able to deep dive into paging and sorting repository interface. And paging and sorting repository interface exposes these two methods to support sorting and pagination. And paging and sorting repository interface, it internally again extends Crude repository interface. And just press Ctrl and click on this Crude repository interface. You can able to go into this Crude repository interface and you can able to see Crude repository interface exposes all these methods. Okay, so mainly we will use save all, find by id, okay, and delete by id, delete all. So these are the very important Crude methods that Crude repository interface exposes. And you can able to see Crude repository interface in turn extends a repository interface. Just press Ctrl and click on this repository interface and you can able to see repository interface. It does not contain any methods. It means that repository interface is basically a marker interface. Okay, and in a repository interfaces hierarchy, repository interface is basically a root interface. Alright, so let's recap the repository interfaces hierarchy again. So we have a Jpa repository interface. It in turn extends paging and sorting repository interface. It in turn extends Crude repository interface. It in turn extends repository interface. So this is how the repository interfaces hierarchy looks like. Alright, now let's go and let's see the implementation class of Jpa repository interface. Well, just go ahead and expand this support package and just scroll down a little bit and you can able to see here simple Jpa repository class. So just go ahead and double click on it and you can able to see simple Jpa repository is the class. It internally implements Jpa repository interface and its methods. Okay, So simple Jpa repository is the default implementation class which provides implementation for all the Jpa repository interface methods. Okay, simple Jpa repository class implements Jpa repository implementation interface, and Jpa repository implementation interface internally extends Jpa repository interface. It means that simple Jpa repository class, it indirectly implements all the methods of Jpa repository interface. For example, Jpa repository interface has all these methods. For instance, find all by ID, save all, flush, save and flush, save all and flush, delete in batch, delete all in batch, okay, and find all. So all these methods basically, simple Jpa repository class implements. For example, if we can just scroll down and you can able to see delete by ID method implementation and delete method implementation. Okay, delete all by ID, delete all by ID in batch, delete all, okay, delete all in batch. All right, so basically simple Jpa repository class, it implements all the methods of Jpa repository interface. Well, if we can closely observe this implementation class, this class is annotated with add transactional annotation. It means that simple Jpa repository class, it already provides a transaction support for all its methods. So we don't have to again provide a transaction support for these methods. For example, delete by ID method. So this method is annotated with add transactional annotation. It means that this method provides support for transaction management. And similarly, delete a method, delete all by ID method. Okay, so all these public methods are by default transactional. We don't have to again provide add transactional annotation to make these methods transactional. Okay, so this is a very important. Just remember, simple Jpa repository is the default implementation class which provides implementation of all Jpa repository interface methods. Okay, and second important point is simple Jpa repository class, it by default provides a transaction support for all its methods. Okay, and we don't have to again make its methods transactional. Alright, so these are the few points you have to keep in mind whenever you use Jpa repository interface in your project. Alright, I hope you pretty much understood the repository interfaces and its implementation in a Spring Data JPA module. Well, let me recap what we have done in this lecture. We have basically decompiled Spring Data JPA jar file and we understood the important interfaces like Jpa repository interface and its methods, Jpa repository interface internally extends paging and sorting interface, paging and sorting repository interface, it internally extends Crude repository interface, Crude repository interface, it internally extends a repository interface. Alright, we have seen all this hierarchy and we have also gone through its implementation class, that is simple Jpa repository class. Alright, and by default all the methods in a simple Jpa repository class are by default transactional. Alright, great. I will see you in next lecture. Hi, welcome back. In this lecture, let's take a look into steps to create and use Spring Data JPA repository. Well, in order to create Spring Data repository in our Spring Boot project, we typically follow these steps. Well, first we create a repository interface which extends Jpa repository interface. Next, we basically add custom query methods or finder methods to the created repository interface. Well, basically this is the optional step. If we want, we can add a query methods or finder methods to the repository interface. Well, third step is inject the created repository interface to another component and use the implementation that is provided automatically by Spring Data JPA. Let's go through these steps in detail. Well, in order to create a repository interface, we basically create an interface, for example, product repository, which extends Jpa repository interface. And Jpa repository interface basically takes two arguments. First is the Jpa entity name and second is the primary key type. Well, consider we have product Jpa entity in our Spring Boot application and we want to create Spring Data JPA repository for product Jpa entity. Well, we basically create an interface like this, product repository, which extends Jpa repository, and we pass Jpa entity name and the primary key type. Well, primary key type here is, for example, look at here, product Jpa entity has ID of type integer. So this is the integer basically we pass as a second argument to the Jpa repository. Okay, so Jpa repository basically is a generic, so we have to pass a wrapper class as an argument. Alright, this is how we basically create a repository interface and get all the Crude methods that is provided by Spring Data JPA. Well, we can also add a custom query methods or finder methods to the repository interface. For example, find by name is the query method or the finder method. Well, we'll learn more about query method or a finder method in the upcoming lectures. So this is basically an optional step. If you want, you can create a query method or finder method as per our requirement. Well, next is how to use this created repository interface in our project. Well, we simply inject this repository interface. For example, look at here, product repository. We are using @auto annotation to inject product repository, and we are calling repository methods. For example, save method, save all, find by ID. Alright, so simply we use @auto annotation to auto wire repository interface, and we call its methods. Okay, so you can inject a repository interface in a service layer components or controller layer components or JUnit classes. Now let's go ahead and let's create a product repository in our Spring Boot application. Well, let's head over to the IntelliJ IDEA and let's go to repository package over here, right click, new, and then choose Java class and choose interface, and just go ahead and give interface name as product repository. Alright, make sure that this should be an interface, and next we need to extend this interface with Jpa repository interface. And look at here, Jpa repository interface takes two arguments. First is the type of the entity, second is the type of the primary key, and this Jpa repository interface should be from this package, that is org spring framework.data.jpa.repository package, and just pass first argument as type of the entity, in our case product Jpa entity, and second long as primary key data type. For instance, if we can go ahead and open product Jpa entity, you can able to see ID has of type long, right? So this is long, and this long we are simply passing to the Jpa repository as a second argument. Alright, now one more important point here is we don't have to annotate this repository interface with @repository annotation here, because as we know that simple Jpa repository is the implementation class of Jpa repository interface, right? So let me quickly open simple Jpa repository class over here. So this simple Jpa repository class is from Spring Data JPA library, and simple Jpa repository class, it internally annotated with @repository annotation. That's the reason we don't have to again annotate this interface with @repository annotation. Okay, just remember this point. Alright, perfect. Now we have created product repository interface which extends Jpa repository interface, and simple Jpa repository class which implements Jpa repository interface and its methods. So we don't have to write any implementation class to implement this interface. Once this product repository interface extends Jpa repository interface, then this product repository interface gets all the methods to perform Crude operations on product Jpa entity. Alright, great. Well, let me recap what we have done in this lecture. Well, we understood the steps that we need to use to create and use Spring Data JPA repositories, and we have also created a product repository in our Spring Boot application. In next lecture onwards, we will deep dive into understanding all the important methods of repository interfaces. Alright, I will see you in next lecture. Hi, welcome back. In this section of the lectures, we'll take a look into important methods of these repository interfaces. So mainly we'll focus on the important methods of Crude repository interface, because you can see These are the methods we frequently use to perform different operations like Crude operations. Okay, we frequently use save method to save or update an entity. We use save all method to save multiple entities at once, and we use find by id method to retrieve or find an entity by id, and we use exist by id method to check whether a entity is exist with a given id or not, and we use find all method to find or retrieve all the entities from the database table, and we use count method to count the records in the database table, and we use delete by id method to delete an entity by id, and we use delete method to delete a given entity, and we use delete all method to delete all the entities or records from the database table. So these are the frequently used methods. So we are going to focus on all these methods in this section of the lectures. And you can see here our product repository interface extends Jpa repository interface. Jpa repository interface internally extends paging and sorting repository interface. Paging and sorting repository interface internally extends Crude repository interface. Right? So once our product repository extends Jpa repository interface, then Jpa repository indirectly extends Crude repository interface, right? Hence, this product repository interface leverages all these methods from all these repository interfaces, because these repository interfaces are extends each other, isn't it? Now let's quickly take a look into what is the relationship between a repository interface and entity manager interface from the Jpa API. Well, basically Spring Data JPA is an abstraction layer on top of Java Persistence API, right? And Entity Manager is an interface of Java Persistence API. Well, basically Spring Data JPA has a Jpa repository interface. It internally uses all the JPA provided methods. For example, this is the Jpa repository interface. Okay, it has methods like flush, save and flush, save, delete, okay, exist, count, find all. So these are all the methods belongs to Jpa repository interface, and all these methods internally uses Entity Manager API to perform different operations with the database. Okay, so this Jpa repository interface methods don't directly connect to the database. These repository methods will first internally get called to the entity manager methods, and these entity manager methods will talk with the database. Okay, so this repository is basically is a abstraction on top of JPA interfaces or the APIs. Alright, I hope you understood how the Jpa repository methods will internally call entity manager methods to talk with the database. Okay, this is how Spring Data JPA basically works. All the Spring Data JPA repositories internally uses entity manager to talk with the database. Okay, so Spring Data JPA is just an abstraction on top of JPA, that is Java Persistence API. In next lecture onwards, we'll take a look into some of the important and frequently used methods of these different repository interfaces. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll take a look into how to save an entity into the database table. Well, this is one of the common requirement in real-time project to save an entity into the database table, right? Well, in this lecture, we'll see how to use save method from Crude repository interface to save an entity into the database table. Alright, so save method, as name suggests, this allows us to save an entity into the database table. Alright, so basically we can use save method to perform both the operations, save and update. If we are trying to store new entity, then save method will internally call entity manager persist method to save a new entity into the database table. If we try to update an existing entity into the database, then save method will internally call merge method to merge the updated information into the database table. Alright, so in this lecture we'll see how to use save method to perform a save operation. That is, we are going to save an entity into the database table. In next lecture we'll see how to use save method to perform update operation. Alright, let's go and let's head over to the IntelliJ idea and let's see how to use save method to save an entity into the database table. Well, basically you have two options. Either you can write the JUnit test to execute a piece of code, or you can simply implement command line runner interface or application runner interface to run a piece of code. For example, so this is the main entry point class of our Spring Boot application. You can simply implement a command line runner interface. It provides a run method, right? Just go ahead and implement it, and you can write the code here. Okay, and if you run this Spring Boot main entry point class, then this code will be executed. Well, this is the first approach we can use to execute the piece of code as a standalone. Second approach, we can use a JUnit test to test a piece of code. Okay, so basically we are going to write the JUnit test to execute a piece of code. Alright, so just let me do this. Okay, and now go to the product repository interface, select it and right click, generate, and then select test, and by default IntelliJ IDEA will provide a class name as product repository test, so let's keep as it is and go ahead and click on OK. Now you can able to see a repository package will be created under test folder, and within a repository package you can see product repository test class has created. Now let's go ahead and let's annotate this class with add Spring Boot test annotation. Well, basically Spring Boot provides add Spring Boot test annotation to load a full application context of your Spring Boot application. Well, here we want to load a full application context because we want to inject some of the Spring Beans in this class. Okay, so go ahead and choose Spring Boot test annotation to load all the Spring Beans from our Spring Boot application. Now let's go and let's see how to use a product repository and its methods in this class. Well, in order to use a product repository, we have to auto-wire it, right? So let's go and let's use add auto-wire annotation to inject product repository interface. So here we are basically doing a field-based dependency injection. So let me simply create a product repository instance here. Now we have injected or auto-wired product repository interface. Now we are good to call its methods, right? And product repository interface internally extends Jpa repository interface, and Jpa repository interface internally extends paging and sorting repository interface, and paging and sorting repository internally extends Crude repository interface. And we are going to basically look into this save method to save an entity into the database table, right? Well, notice here we are not going to write a real JUnit test cases to test a repository layer components here. Here we are basically writing a JUnit test case to execute a piece of code, right? So basically we use add data Jpa test annotation to test the repository layer components, but here we are basically using add Spring Boot test annotation to load a full application context, so that we can able to inject any Spring Bean in this class and we can simply use it. Alright, so don't worry about how to test the repository layer components. I will create one dedicated section of the lectures to show you how we can test repository layer components using add data JPA annotation, and also will follow BDD style naming convention to write the JUnit test cases. Okay, and here we are basically write the JUnit test case to execute the piece of code. Alright, so I am going to create one JUnit test case here. I will call it as save method, something like this, and let's annotate this method with add test annotation. Okay, so this is the JUnit test case, and within this JUnit test case we are going to write the logic. So basically we need to first create a product object, okay, and then we'll save that product object into the database table, and then we'll display the product information. Okay, so let's go and let first create the product object, product, and then product, new product, and let's go and let's use setter methods to set the values to the product object. Let's go and let's give a product name something like product 1. So just give dummy data, and let's go and let's give description as product one description. Alright, and let's go and let's give a product stock keeping unit, something like, let's say 100 ABC, something like that. Alright, and let's go and let's give a price to the product. So this should be a big decimal, so I am going to call big decimal instance and just pass 100, and product dot set active, let's say true, and next product dot set image URL. So let's give any image URL here, let's say product1.png, something like that, and product dot set what else remaining. Okay, so we don't have to set the last updated and date created fields, because we are using Hibernate provided timestamp annotations to automatically fill the values for these fields. Now let's go and let's save this product object into the database. Well, this is a save method, right? And let's go and let's save this product object into the database. Let's call product repository and call its method, that is save method, and look at here, save method expect entity as a method argument, and go ahead and call this save method and just pass product as a entity. Perfect. And look at here, save method returns the saved entity. In this case the type is product. So let's go ahead and let's take the result of this save method in a product object, let's say saved object, something like that. Okay, now once we save a product object into the database, then we simply display this product information. Okay, I'm going to simply call the sysout over here, saved object, and just call get ID. Well, you might be wondering how the primary key will be generated and it will be assigned to this product object while saving into the database, right? Well, basically save method internally uses Hibernate to create the primary key, and it will assign to product entity, and then it will save into the database, right? And here save method basically return the saved product object, right? And that we are basically storing in the different object, and here we are basically checking whether this saved object has a primary key or not. Well, in order to print a complete product object, we can use toString method, right? So go to the product class, and here we can simply use add toString annotation from Lombok Library. So Lombok Library will basically provide a toString method at a runtime for this class. So go ahead and call toString annotation over here, and then let's go back to our test class, and here we can simply put another sysout, okay, and just call toString method of saved object. Okay, now let's go and let's run this JUnit test case, and let's see how this works and how Hibernate will create SQL queries behind the scene. So let me execute this JUnit test case now. Well, one more important point here is we are using sequence as a primary key generation strategy, right? And Hibernate will trigger a few more SQL statements to get the sequence from the table and update the sequence into the table. Now let's go and let's see the output of this JUnit test case. And here you can see Hibernate generated a couple of SQL statements to get the sequence from the sequence table and update the sequence in the sequence table. So these are the couple of Hibernate generated SQL statements to track the sequence into the sequence table. Next, you can see Hibernate generated SQL statement, that is insert SQL statement to insert a record into the database table, right? And these are the two sysout prints. For example, we have provided a sysout to print the primary key and the product information, right? Here you can see. Alright, so these sysout prints a primary key as well as product information. Alright, it means that Hibernate behind the scene created an insert SQL query to save a product record into the database, And as we are using sequence as a primary key generation strategy, so Hibernate will trigger a couple of SQL statements to get the sequence from the sequence table and update the sequence into the sequence table. Now let's head over to the Mysql Workbench and let's see how this record is saved into the table. Well, let's go ahead and let's refresh the schemas, and let's go ahead and let's select the rows from the products table, and you can able to see a product record is successfully saved into the database table. And let's also see the sequence, and you can see 2. Okay, so sequence is also updated successfully in the sequence table. It means that we have successfully used save method to insert a product record into the database table. In next lecture, we'll see how to use save method to update an existing entity. Alright, I will see you in next lecture. Hi, welcome back. In previous lecture, we have seen how to save an entity using save method. In this lecture, we'll see how to update an existing entity using save method. Well, as I mentioned, we can use save method to perform two operations like save operation as well as update operations, right? So in case of save operation, save method internally uses entity manager provided persist method, and in case of update operation, save method internally uses merge method to merge the updated information. Alright, so let's switch to the IntelliJ IDEA and let's see how to use save method to perform update operation. I'm going to head over to the IntelliJ IDEA and go to the test class, and we are going to simply write the JUnit test case to execute the piece of code. And here I'm going to use a test method, something like update using save method. Alright, and let's go ahead and let's annotate this method with add test annotation so that JUnit framework can recognize this method as a JUnit test case. Alright, perfect. Now you can see in the database table we have already a product record, right? So let me show you. So we have already a product record into the database table. Now we are going to update this product record. Okay, so you can see product ID is 1, right? In order to update an existing entity into the database table, we are going to perform different steps. So first, what we're going to do is we're going to find or retrieve an entity by ID from the database, and then what we'll do, we'll update retrieved entity, update the entity information, and then finally we save the updated entity into the database table. Alright, so in order to retrieve a entity from the database table, first we need to have ID, right? And as we know that product has ID 1, right? So let's go and let's declare ID here. Let's say long ID equal to 1. So we are going to basically update a product with ID 1, and then we need to call find by ID method to retrieve a record from the database. So we're going to simply call here product repository, and then we call find by ID method. And look at your find by ID method basically takes ID of type long, and find by ID method returns optional of type product. So go ahead and select this find by ID method over here and just pass ID as a method argument, and then call get method to get a product object from the optional class. Now we got the product from the database table. Let's go and let's update the information of this product object. So if you can go back to database, here you can see product name is product 1, okay, and product description is product 1 description. So let's go and let's update these two fields. So I'm going to say set product name something like updated product 1, okay, and product dot set description, let's say updated product 1 description, something like that. And now let's go ahead and let's save this updated product object into the database table. So in order to do that, let's call save method, right? So just call product repository and its method, that is save method, and just pass a product object to the save method. Well, in this case, save method will basically update the product information into the database table, because product is the existing entity in the database table, right? And product has a primary key, isn't it? That's why save method internally call entity manager's merge method to merge this updated information into the database table. Alright, let's see how this works. Let's go and let's execute this JUnit test case, and let's see how Hibernate will generate SQL statement behind the scene. Well, let's go and let's see the output of the JUnit test case, and you can see Hibernate has generated a lot of SQL statements, and let's understand one by one. If you go back to our JUnit test case, we have called findById method to retrieve a product from the database by using ID, right? So Hibernate basically created a select SQL statement for findById method behind the scene. And if you look at the where clause here, Hibernate generated SQL statement, that is select SQL statement. It has a where clause with ID. Okay, and next, in order to update the information, Hibernate triggered one more select SQL statement to retrieve product by ID, and then it will update the product information. Alright, so look at here the update SQL statement. Alright, so as I mentioned earlier, we can use save method to perform both save and update operations, and in this case you can see Hibernate behind the scene generated update SQL statement to update the product information into the database table. Alright, so this is a very important. You should have to understand how to use save method to perform save and update operations, right? So by looking into this SQL statement that Hibernate generated behind the scene, we can able to see that how save method works and how it uses Hibernate to save and update the information into the database table. Alright, I hope we understood how to use save method to update an entity into the database table. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to retrieve an entity from the database table using findById method. Well, findById method is basically from Crude Repository Interface. And findById method returns optional type entity. Alright, so look at here, as name suggests, findById method allows us to get or retrieve an entity based on the given ID from the database table. Alright, let's head over to the IntelliJ IDEA and let's see how to get or retrieve an entity based on the given ID from the database table using findById method. Well, let's head over to test class, and here we are going to quickly write the JUnit test case, and we will write the logic to retrieve an entity from the database table using findById method. findById method. Alright, and let's annotate this method with add test annotation. Now let's head over to the Mysql Workbench and let's see what is there in a products table. Well, here you can see we have one product record in the products table. Alright, now let's pass this ID 1 and retrieve this product by using findById method. Alright, it's pretty simple. Let's first declare here the ID. In our case it is 1. So typically in real-time project, this ID basically comes from the client. Now in order to test findById method, we simply hardcode the ID as a 1 here. Okay, now let's go ahead and let's declare a product object over here and then call product repository, and it has findById method. Alright, and look at here, findById method takes ID type long and it returns optional type product. Okay, just go ahead and select findById method here and just pass ID to it. And as findById method returns optional, so we can simply call get method to get a product object from the optional type. Perfect. Now we got a product object by using findById method. And if you can simply press Ctrl and you can click on find by ID method, you can able to see that find by ID method is belongs to Crude repository interface. Okay, let's go back to our code. Now let's run this JUnit test case and let's see how Hibernate will create SQL query behind the scene for this statement. Alright, let's run the JUnit test case. So this is simply like we run the main method, right? So this JUnit test case we simply run as a standalone to just check this piece of code. Alright, look at here, test passed, and let's see the output of this JUnit test case. And here you can able to see Hibernate generated select SQL query. Okay, so here select all these product columns from products table where product ID equal to 1. Okay, so this is the basically Hibernate generated SQL query behind the scene for find by ID method. Well, whenever we have a requirement to retrieve an entity from the database table using Spring Data JPA, then you can go ahead and use find by ID method of Crude repository interface. Alright, and find by ID method internally uses Hibernate to generate SQL query like this. This is the select SQL query. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to use save all method to save multiple entities into database table. Well, save all method is basically from Crude repository interface, and save all method returns a list of iterable objects. Okay, so whenever you have a requirement to save multiple entities into a database, then you can go ahead and use save all method. Alright, let's head over to the IntelliJ IDEA and let's write the logic to see how to use save all method to save multiple entities into the database table. Let me head over to the IntelliJ IDEA and let's quickly write the method over here, void, and let's call it as save all method, and let's annotate this method with add test annotation. And let's head over to the Mysql Workbench and let's see how many records are there in a products table. Well, let me refresh the schemas and you can able to see only one record we have in a products table. Let's go and let's insert multiple records in a products table using save all method. Well, let's go back to IntelliJ IDEA again, and in a save method we have already written code here to create the product object. So I'm going to simply copy this piece of code and I'm going to paste it here. Okay, so let me quickly change the values. Let's say product 2, and this is product 2 description, and let's say the stock keeping unit something like ABCD, and let's change price from 100 to 200. Okay, and the image URL product2.png. Okay, and I will create one more product record. Let me quickly copy this and paste it here, and let's call it as product 2, or let's call it as product 3, and let's change the values. Product 3 description, and this is 100 ABCD, let's call it as E, and let's change the price from 200 to 300, and also the image URL. Alright, and also replace this object reference here, product 3. Alright, now we have created two product objects. Let's go and let's use save all method to save these product objects. Let's go and let's call product repository, and it has save all method. Well, look at here, save all method basically takes a list of iterable entities and it returns a list of type entity. Okay, let's go and let's select save all method here, and it expect list. So go ahead and create the list, and it has op method. Alright, and let's go and let's pass the product object to this op method. Perfect. Well, what we have done basically, we have called save all method and we have passed a list of product objects to the save all method. Now let's go back to the Mysql Workbench and if you can see, the products table contains only one record. Now let's go and let's run this JUnit test case and let's see how this save all method works and how Hibernate will create SQL query for this save all method behind the scene. Well, let me quickly run the JUnit test case now. And there we go, test passed, and let's see the output of the test case. Well, look at here, Hibernate have generated a lot of SQL statements. Let's understand these SQL statements one by one. Well, post this SQL statement is to select a value from the sequence table, and this SQL query to update a value in the sequence table. Okay, so basically whenever we insert the record, then Hibernate will create these two SQL statements to maintain a sequence as a primary key in the sequence table. Okay, so this is for inserting a single record, and next these two SQL statements for inserting a second record. Okay, because here you can see save all method basically insert two product objects, right? And here you can see there are total 4 SQL statements for managing the sequence values in the sequence table. Okay, so first one, this is second, and this is third, and this is fourth. And then later Hibernate create insert queries to insert the records in the database table. And here you can see save all method basically insert two product records, right? That's why you can able to see Hibernate has generated two insert SQL statement. So this is one and this is second. Alright, I hope you understood how save all method works. Well, basically save all method internally uses Hibernate to generate insert SQL statement to insert individual records into the database table. Now let's head over to the Mysql Workbench and let's see how these records are inserted in the products table. Well, let me head over to the Mysql Workbench and let me select records from the products table, and you can able to see product 2 and product 3. So these records are inserted in the products table. Well, whenever you have a requirement to save multiple entities at the same time, then you can go ahead and use save all method. Well, save all method is basically it does a bulk insertion operations. Alright, great. I hope you understood how to use save all method to save multiple entities in the database table. Alright, I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to retrieve all the entities from the database table using find all method. Well, basically find all method belongs to Crude Repository Interface, and find all method returns a list of iterable objects. Alright, so whenever you have a requirement to retrieve or get all the entities from the database table, then you can go ahead and use find all method. Alright, let's head over to the IntelliJ IDEA and let's quickly write a piece of code to see how to retrieve all the entities from the database table using find all method. Well, let me head over to the IntelliJ IDEA and let me minimize this, and I will go at the bottom, and here I am going to quickly create a method void, and let's call the method name something like find all method. Alright, and let's annotate this method with add test annotation. Well, let's head over to the Mysql Workbench, and you can able to see there are 3 records in a products table, and once we call find all method, then find all method should return all these 3 records from the products table, right? So let's go ahead and let's see how to use find all method to retrieve all the records from the products table. Well, within this method, here I am going to declare a list, and then I am going to pass product as a type, and let's go and let's use product repository over here. It has find all method, and look at here, there are multiple find all overloaded methods, and I'm going to use this find all method, that is first one. It don't have any method arguments, right? And find all method returns a list of entities, in our case list of products. Alright, let's go and let's select find all method, That's it. This find all method returns a list of products, and that products we have stored in this list of products object. Okay, now what we can do, basically we can simply print the product's name from the products list. For that, here I'm going to use for each method, and for each method takes a functional interface. So we're gonna use a lambda expression to implement this functional interface. So let me quickly write the lambda expression here, and within a lambda expression I am going to put one sysout to just print product name. Okay, great. Now let's run this test case and let's see how this find all method works, and how this find all method use Hibernate to create the SQL statement behind the scene. Let's run the JUnit test case now. And there we go, the test passed, and let's see the output of the test case. Well, look at here, select SQL query that is generated by Hibernate behind the scene. So this is a plain select SQL query. There is no where clause for this select SQL query, right? And this select SQL query basically retrieve all the records from the products table. All right, and here basically you can see we have printed product name in the for each loop, right here, by using for each method, right? So that is what we can able to see here in a console. All right, it means that find all method internally uses Hibernate to generate this SQL select query to retrieve all the records from the database table. All right, I hope we understood how to use find all method to retrieve all the entities or records from the database table. All right, so whenever you have a requirement to retrieve all the entities or the records from the database table, then you can go ahead and use find all method. All right, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to delete an entity by ID from the database table using delete by ID method. Well, basically delete by ID method belongs to Crude repository interface. And delete by ID method does not return anything. It simply returns a void. Okay, so whenever you have a requirement to delete a record or entity by ID from the database table, then you can go ahead and use delete by ID method. Well, let's head over to the IntelliJ IDEA and let's write a piece of code to see the usage of delete by ID method. Let me head over to the IntelliJ IDEA. Let me minimize this, and here at the bottom I'm going to simply create a test case. Let's say delete by ID method. Okay, and let's annotate this method with add test annotation. All right, now let's head over to the Mysql Workbench, and here you can able to see there are 3 records in the products table, and we are going to delete the product with ID 1. Okay, so go back to IntelliJ IDEA, and here I am going to declare ID equal to 1. Well, in real-time project, basically this ID comes from the client, and in order to test delete by ID method, we simply hardcode the ID as a 1 here. Okay, now let's go ahead and let's call product repository. It has a delete by ID method. Well, look at here, delete by ID method takes ID of type long and it returns a void. It means it doesn't return anything. Okay, simply call delete by ID method here and just pass ID. Okay, that's it. So this will basically delete a product with ID 1. Okay, so let me format this and let me run this JUnit test case, and let's see how Hibernate will create a SQL statement behind the scene for this delete by ID method. Let me run the test case now. And there we go, test passed, and let's see the output of the test case. And here you can see a couple of SQL statements generated by Hibernate. Well, whenever we use delete by id method to delete a record by id, then Hibernate behind the scene generate these two SQL statements. First SQL statement is to select the product by id, and then second SQL statement is to delete that particular product with id, given id, from the products table. Okay, so Hibernate basically generate these two SQL statement behind the scene for delete by id method call. Okay, now let's head over to the Mysql Workbench and let's see whether this record is deleted or not. Well, let me refresh the schemas and let me select rows from the products table, and you can able to see the record 1 is successfully deleted from the products table. Well, whenever you have a requirement to delete an entity by given id from the database table, then you can go ahead and use delete by id method. Alright, great. I will see you in the next lecture. Hi, welcome back. In previous lecture, we have seen how to delete an entity by id from the database table using delete by id method, right? In this lecture, we'll see how to use delete method to delete an entity from the database table. And notice here, delete method, it does not take id, it takes a whole entity object. Alright, and delete method is basically from Crude Repository Interface. And look at here, delete method does not return anything, it simply returns a void meaning nothing, right? And delete method takes entity object. Alright, now let's see how to use this delete method to delete an entity from the database table. Let's head over to the IntelliJ IDEA and let's quickly write the piece of code to see how to use delete method. Well, here I'm going to quickly create a method. Let's say void delete method, and let's annotate this method with add test annotation. And if you can head over to the Mysql Workbench, and we have two records in the products table. Now we are going to basically delete the record with id 2. Well, in order to use a delete method to delete a particular entity from the database table, first we need to retrieve that particular entity from the database table by using id. Okay, so here basically we need to perform two steps. First we need to find an entity, okay, by id, and then we call delete method and we pass the entity that we are going to delete. Okay, first let's go and let's retrieve a product by id. So first we'll declare the id. Let's say id equal to 2. Okay, so we are going to basically delete a record with id 2, right? So that is what I have just initialized id with value 2. So ideally this id basically comes from the client, right? So in order to test this delete method, we just simply hardcode this id over here. And next, so this delete method basically expect entity as a method argument. So let's go and let's retrieve this entity from the database table. So in order to retrieve, we're gonna call find by id method, right? So simply call here product repository. It has find by id method, and we're gonna pass id. So find by id method basically returns optional, okay, of type entity. So let's go and let's call get method to get a product object from the optional type. Now we have a entity, that is product entity. Now we can call delete method and we simply pass this product entity to the delete method to delete from the database table. Well, let's call product repository over here and then simply call its method, that is delete method. And look at here, delete method takes a entity as a method argument and it does not return anything, it returns void, right? So let's go and let's select delete method and just pass product object to it. That's it. Now let's go and let's run the test case and let's see how this delete method works and how Hibernate will create SQL statements behind the scene for this delete method. Well, let me run the test case now. And there we go, test passed, and let's see the output of the JUnit test case. And here you can able to see a lot of SQL statements generated by Hibernate. Let's understand these SQL statements one by one. So this first SQL query, that is select SQL query, is for find by ID method. Well, if you can go to the code, you can see here we are calling find by ID method, and it takes ID as a method argument, right? And this find by ID method behind the scene uses Hibernate to generate this select SQL statement. Alright, and look at here the where clause. Here in a where clause, ID equal to placeholder, and this placeholder will be replaced with the actual ID value while executing this SQL query. Alright, so this is the first SQL statement. Well, basically this delete method, it internally first select the record by using ID. For that, it create this SQL statement, that is select SQL statement, and then it will trigger one more SQL statement, that is delete SQL statement, to delete that particular record by ID. Okay, that's why delete method internally create these two SQL statement by using Hibernate. Okay, and earlier we have seen in case of delete by ID method also there were two SQL statements generated behind the scene by the Hibernate, right? And for delete method as also we can able to see Hibernate generated two SQL statement to delete the record. First SQL statement is to retrieve record with the ID, and then second SQL query to delete that record with the ID. So if we can closely observe these two delete methods, like delete by ID method and delete method, so there is some performance impact. Okay, so when we were using delete by ID method, it behind the scene generated two SQL statements, right? First one is select and second one is delete. But in case of delete method, we are basically pass a entity instance as a method argument. But in order to fetch this instance, we need to make find by ID method call, right? And this find by ID method call basically trigger one more SQL statement behind the scene. That's why whenever you have a requirement to delete an entity by ID, then you should use delete by ID method, because it will trigger two SQL statement. And if you use delete method, then you need to first get the entity by ID by using find by ID method. This will trigger SQL statement behind the scene, and then when you call delete method, then this will basically trigger two more SQL statements. You can able to see first one is select SQL statement and second one is delete SQL statement. Whenever you have a requirement to delete an entity from the database table by using ID, then you should use delete by ID method. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to delete multiple entities from the database table using delete all methods. Well, basically delete all method is from Crude repository interface. And if you can able to see here, there are two overloaded delete all methods. Well, first delete all method takes list of iterable entities, and second delete all method does not take any method arguments. Alright, let's see how to use these two delete all methods to delete multiple entities from the database table. Let's head over to the IntelliJ IDEA and let's write a piece of code to see how to use these delete all methods to delete multiple entities from the database table. Well, let's head over to the IntelliJ IDEA and let me minimize this and let me quickly create the method over here. Let's say delete all method and the return type should be void. Alright, and let's annotate this method with add test annotation. And let's head over to the Mysql Workbench and let me trigger this SQL statement, that is select star from products, and you can able to see there is only one record in the database table. Okay, so now what I'm going to do is I'm going to insert one more record into this products table. Well, in order to insert one more record, I'm going to run this save method test. So this will basically insert this product 1 entity into the database table. Well, let me quickly run the test case. So this will basically insert this record into the database table. Alright, test passed, and let's head over to the Mysql Workbench and let's select rows from the products table, and you can able to see there are total 2 records in a products table. Now we are good to use delete all method to delete these multiple records from the products table. Now let's go back to IntelliJ IDEA and go back to our method here, and let's call product repository object, and let's call delete all method over here. So delete all method basically delete all the entries or the records from the database table. Alright, that's it. Now let's run the test case and let's see how this delete all method works and how the Hibernate will generate SQL statement behind the scene for this delete all method. Well, let me run the test case now. There we go, test passed, and let's see the output of the test case. And here you can able to see Hibernate has generated a couple of SQL statements. So first one is to select all the records from the products table, right? So when we were using delete and delete by ID methods, that time Hibernate generated select SQL query to select a particular record, right? But in case of delete all method, Hibernate basically execute or create this select SQL query to select all the records from the database table, right? There is a no where clause you can able to see. This is a plain select SQL query to select all the records from the product table. Next, Hibernate will trigger individual delete SQL statements to delete individual records from the database table. Well, if you can closely observe these SQL statements, Hibernate first select all the records from the database table, and then based on the records it will create the delete SQL statements. For example, in our products table we have 2 records, right? So Hibernate behind the scene created 2 delete SQL statements to delete 2 product records from the products table, right? And if you can see the where clause here, it will pass the ID to delete that particular record from the products table, right? And let's say if there are 5 records in the products table, then Hibernate will create 5 individual delete SQL statements to delete 5 records from the products table, right? So this SQL statement is to get all the records from the database table, and then based on the records it will create a delete SQL statements and then it will pass ID to delete that particular record from the database table. Alright, I hope you understood how this delete all method works and how Hibernate will create SQL statements behind the scene for this delete all method. Well, whenever you have a requirement to delete all the entities or records from the database table, then you can go ahead and use delete all method. Well, there is one more delete all method which takes a list of iterable objects, and if you can see in a Mysql Workbench, let me select rows from the products table. There are no records in the products table, right? Let's first insert couple of records in a products table, and then we'll see how to use delete all method which takes a list of iterable objects. So in order to insert multiple products objects, I'm gonna execute this save all method. So this basically insert 2 product records in the database table. So let me execute this JUnit test case. And there we go, test passed. And let's head over to the Mysql Workbench and let me select rows from the products table, and you can able to see there are 2 records inserted in the products table. Now we are good to use delete all method to delete these records from the database table, and you can able to see the ID 5 and 6. Okay, now let's head over to the IntelliJ IDEA and let's write the logic to use delete all method to delete specific entities from the database table. Okay, now what I will do, I will comment out this. Okay, and I will get a product, individual product from the products table. Well, in order to get a product by ID, then what we need to do is we need to simply call find by ID method. And if you can see the ID for the records 5 and 6, right? So we need to pass 5 here. Alright, and then call get method. So this will return a record, that is product record with ID 5. Similarly, let's get one more entity from the database table by using find by ID method. Let's call it as product 1 product repository, and then find by ID method, and just simply pass 6 as ID and then call get method. Perfect. Now we have 2 product entities. Okay, now we are good to call delete all method, right? Let's call product repository and then delete all method. So make sure that you choose delete all method which takes list of iterable objects, this one. Let's select it, and it expect list as a method argument. Let's create a list here and just pass product comma product 1. It means that we are using this delete all method to delete a specific entities from the database table. We are not deleting all the entities. We are specifying here the entities that we are going to delete from the database table, right? So let me run the test case and let's see how this delete all method works and how Hibernate will create SQL statement behind the scene. Alright, test passed, and let's see the output of the JUnit test case. And here you can see a lot of SQL statements generated by Hibernate. So we have called find by ID method twice, right? So these 2 find by ID methods, behind the scene create SQL statements. So this SQL statement used to retrieve a product with ID 5, this one, and second SQL statement, that is select SQL statement, to retrieve a product with ID 6. Alright, and remaining these 4 SQL statements, that is created by delete all method. And again you can able to see there are 2 delete SQL statements to delete 2 entities from the database table. In our case, we are deleting 2 product entities, right? That's why you can able to see there are 2 delete SQL statements. Alright, I hope you understood how this delete all method works and how Hibernate will create SQL statement behind the scene for this delete all method. Alright, great. I will see you in the next lecture. Hi, welcome back. In this lecture, we'll see how to count a number of records that exist in the database table using count method. Well, count method is basically from Crude Repository Interface, and count method returns of type long. Okay, so whenever you have a requirement to count the number of records that are exist in the database table, then you can go ahead and use count method. Alright, let's head over to the IntelliJ IDEA and let's write a piece of code to see the usage of count method. Let me head over to the IntelliJ IDEA, and here I'm going to quickly write the method. Let's say void count method, and then let's annotate this method with add test annotation. Okay, let's head over to the Mysql Workbench and let's see how many records are there in a database table. Let me select rows from the products table, and you can able to see there is only one record in the products table. Now let's go and let's call the count method over here, and basically count method returns long type. So declare here long, and let's say count equal to product repository, and it has a count method. So let's go and let's call the count method over here, and let's put one sys out to just print the count. Alright, that's it. let's go and let's run the test case and let's see how this count method works and how Hibernate will create the SQL statement behind the scene for this count method. And there we go, you can able to see test passed, and let's see the result of this test case, and you can able to see the count is 1. And here is the Hibernate generated SQL statement. Select count star from products table. Alright, so this is how the Hibernate will create a SQL statement to count the number of records in the database table. Alright, and if you go back to Mysql Workbench, you can able to see there is only one record in the database table, right? That's the reason the count is 1. Well, let me insert a few more records and let's see how this count method works. Well, I'm going to run this save all method to insert these two records. Okay, so let me run this test case and we'll insert these two product entities into the database table, and let's see how this count method works. Okay, let me go back to Mysql Workbench and let me select the rows from the products table. Well, you can able to see there are 3 records in the products table now. Alright, now let's go and let's call the count method. Okay, so let's run this test case and let's see how this count method works. Alright, so look at here, test passed, and let's see the result of this test case, and you can able to see count method returns 3 because there are 3 records in the database table. Alright, so whenever you have a requirement to retrieve a number of records in the database table, then you can go ahead and use count method. Alright, great. I will see you in the next lecture. Well, this is a very basic series or a course on Spring Data JPA, but if you want to master Spring Data JPA, then I am going to suggest my Udemy course, that is Master Spring Data JPA with Hibernate. So this is a 15-hour course, and in this course you will learn everything about Spring Data JPA, and you will also learn how to build a domain model relationship for simple e-commerce project using Hibernate ORM framework. Well, this Master Spring Data JPA with Hibernate course is highest rated course on Udemy. So this is a very popular course on Udemy. So I am going to suggest you to check out this course in order to learn Spring Data JPA with Hibernate in depth.